Now, example 2.5. A. Determine the electrostatic potential energy of a system consisting of two charges 7 microcoulomb and minus 2 microcoulomb and with no external field placed at minus 9 centimeter 0 and 9 centimeter 0 respectively. B. How much work is required to separate the two charges infinitely away from each other? C. Suppose that the system of charges is now placed in an external field E equal to A into 1 upon R square, where A, that is 9 into 10 raised to 5 coulomb per meter square. What would be the electrostatic energy of the configuration? Clear? Now, solution. First, we have to find the electrostatic potential energy of a system of these two charges, and these two charges are placed at these 2 points. So, we have the equation for the potential energy of a system of two charges, and that is 1 upon 4 pi epsilon 0 or k q1 q2 upon r square. Sorry, r. Right? Now, here q1, that is 7 microcoulomb, so that is 7 into 10 raised to minus 6 coulomb. q2, that is minus 2 microcoulomb, so that is minus 2 into 10 raised to minus 6 coulomb. Now, distance between those two charges R12. So, one charge is at minus 9 centimeter and another one is at plus 9 centimeter. It implies that the distance between those two charges, that is 9 plus 9, that is 18 centimeter. So, that is 0.18 meter. Now, if we substitute all these values here, then k, that is, or 1 upon 4 pi epsilon 0, that is 9 into 10 raised to 9. Then 7 into 10 raised to minus 6 minus 2 into 10 raised to minus 6. So, directly we can write 7 into minus 2 into 10 raised to minus 12. Divided by 0.18, your answer turns to minus 0.7 joule. Now, second question here. How much work is required to separate the two charges infinitely away from each other? Now, see here. If we separate these two charges infinitely away from each other, then for that work done, that is the change in potential energy. Now, change in potential energy, that is U final minus U initial. U final means U2, initial means U1. So, U2 minus U1. Now, when these two charges are separated by infinite distance, then as per this equation, you can understand if this distance is infinite, then the potential energy will be 0. So, U2, that is 0, and U1. So, at this particular position, we already calculated. So, minus 0.7. So, 0 minus 0.7. So, your answer, that is 0.7 joule. Then third question. Now, the system of charges is placed in the external field. And now, what is the electrostatic energy of the configuration that we have to calculate? Now, the potential energy due to the interaction between two charges, this 1 upon 4 pi epsilon 0 q1 q2 upon r12, that will remain as it is. But in addition to that, two more potential energies will be there. One, that is due to interaction of charge q1 with electric field, and another one, that is interaction of charge q2 with electric field. Clear? Now, to find out the potential energy of q1 in the given electric field at a particular point, we have to find the potential at that point, because potential energy, that is Q into V. Now, here relationship E, that is A into 1 upon R square, that is given to you. Now, we already derived the relationship between electric field and potential, that is E equal to minus dV by dr. So, dV, that is minus E dr. Now E, that is 1 upon r square into A. So we can write V, that is integration minus E dr. E is replaced by A upon r square, and if you integrate 1 upon r square, then that is minus 1 upon r. A is constant, so keep it as it is. So finally you will get V, that is equal to A by r. Now the net electrostatic energy of the configuration in the external field, that is Q1 into V at position R1 plus Q2 into V at position R2 plus Q1 Q2 upon 4 pi epsilon 0 R1 2. Now both the charges are placed at 9 centimeter from the origin. So we can write A upon R1 for VR1 into Q1. Then for VR2, A upon R2 into Q2 plus Q1 Q2 upon 4 pi epsilon 0 R. Now substitute the values. So A, that is 9 into 10 raised to 5. Q1 7 into 10 raised to minus 6. 9 centimeter, so 9 into 10 raised to minus 2 meter. Plus again A 9 into 10 raised to 5, Q2 that is minus 2 into 10 raised to minus 6. Again distance R2 that is 9 centimeter, so 9 into 10 raised to minus 2. And this Q1 Q2 upon 4 pi epsilon 0 that we already calculated here. So substitute directly minus 0.7. And now if we solve this one, our answer will turn to 49.3 joule. Clear to all of you?